We have seen that the atmosphere on the young Earth was released by giant volcanoes, but that atmosphere was very different from the one we know and breathe today. The atmosphere today contains 78% nitrogen, which consists of two atoms of nitrogen joined together by covalent bonds to make a molecule. And honk tells you that there must be 3 bonds between them. 1, 2, 3, 4, HONC. So they are held together very tightly, these two atoms of nitrogen. 3 bonds hold them very tight. It takes a lot of energy to split up a nitrogen molecule, and so it is almost inert. Most of the rest of today's atmosphere is made of oxygen. An oxygen molecule consists of 2 oxygen atoms, and honk tells you that there must be 2 covalent bonds between them. The atoms are therefore not held so tightly as in a nitrogen molecule, and what is more, oxygen atoms can easily attract and steal electrons belonging to other molecules. That is why, given a spark of energy, things will easily burn in the presence of oxygen. Everything else in today's atmosphere makes up the remaining 1%. This, for example, is carbon dioxide. But the atmosphere on the young Earth was very different. It consisted of gases which had been the ices on stardust. One of these was made by combining hydrogen with a nitrogen atom. We call it ammonia. Can you work out what nitrogen must look like? You already know how many covalent bonds a nitrogen atom can form, don't you? Honk tells you HONC, N for nitrogen, so there must be 3 covalent bonds. And you know that hydrogen can form HONC, 1 covalent bond. So to make ammonia with 1 nitrogen atom, how many hydrogens would you need? Well, the answer is 3. So this is a molecule of ammonia. Another gas in the atmosphere was methane, and it was an atom of carbon combined with hydrogen atoms. Hydrogen atoms obviously are the commonest atoms in the universe, so that's why other atoms tended to combine first with hydrogen. So how many hydrogen atoms can a carbon combine with? What does methane look like? Well, HONC tells us that carbon has 4 covalent bonds, so there are 4 hydrogen atoms. We've already seen that water vapour is made of oxygen combined with hydrogen, and HONC tells us that oxygen can make 2 covalent bonds, so there must be how many hydrogen? 2. 2 hydrogens in a water molecule, as we've seen before. The young atmosphere probably also contained carbon dioxide, which combines carbon with oxygen, and it takes a bit of juggling to show or to work out the actual configuration. There are double bonds between the 2 oxygen atoms and the carbon atom. We're not sure what other gases the young atmosphere contained.